have been very profound on my career, and his interventions have actually ended up in getting me a job where I am right now. So I thought...
What's the other one? The top one is the pointed, the bottom one is the advance.
No, that's the one I was pushing.
The other one in the middle go back.
Okay. So I wanted to interject a few sentences in here in Franco's career to make some statements about my personal career in sort of theory and experiment and enjoying physics. So my own journey actually didn't start until the early 1980s when I arrived at Brookhaven and met these two gentlemen, Rick Aston and Dave Warner. And as you can see, if people are signaling that you can't hear me, I'm usually pretty loud, right? Okay, so Rick Aston and Dave Warner, who were so excited about the interacting boson model. They were excited about the inherent symmetries, the fact that you could parameterize parameters and describe whole areas of the charted nuclides in terms of very simple parameters, and as you can see, trail along the symmetry triangle to describe various things. So this is a publication from 1984, which shows that you could describe the entire z equals 50 to 82 area in terms of the parameters of the symmetry triangle. This journey took us further. I should use my own computer. To the experimental part where we actually look for an example of a U5 symmetry nucleus. Well, we didn't look for it, but we found it, as most things in experimental physics. And finally, Franco was visiting University of Notre Dame while I was a postdoc in California, and they were looking for a nuclear physicist, and they finished their hiring the interviews and everything else. They decided on their candidate, and he suggested to them that they invite me, and here I am, 22 years or something at Notre Dame. Hard to believe even for me. So most of us in physics talk about our successes, but I'm going to start talking about one of my failures, which is one of the things I tried as a postdoc. Sort of new, was a completely theoretical effort. What I tried to do was use the IBM binding energies to try and see if we could extract some information about nuclear masses. Now you may all laugh because several people in this audience have succeeded in doing that. Heath has managed, Jorge has managed, and some various aspects of masses we'll hear about from Burju as well a little bit later on. But in any case, this was my first attempt and it didn't work. But we learned quite a lot. And from the various developments in effective boson numbers, Bianchi-Anensky, we actually managed to develop a semi-empirical mass model using concepts of Epstein from Alejandro and PNN from Rick and Dave Brenner and company, and effective boson number earlier on from a number of different people. So what am I going to talk about today? The reason I showed the older work that didn't succeed, the goal for that research was still to try and understand or describe nuclei in the R process. So the R process in nuclear physics today, we keep saying, is one of the main reasons that we're building all these facilities around the world. We are going to make very exotic nuclei. And if you look at the map of the world, from Canada to US, to Europe, France, Germany, facilities coming online that can study a lot of these nuclei that beforehand we thought were so difficult to reach. So the goal of what I'll be talking about today is still to try and take a look at all of these measurements, to try to use some theoretical guidance as well as some experimental possibilities to see what kinds of things we should measure. And I'm going to tell it in the way that I was advised as a graduate student never to tell a story, which is in the sequence that it happened. So just bear with me and we'll live through it. So